position, path length and displacement. Let me ask you a question. You started from here, you went to uncle, you went to auntie, you went to your grandfather, and then you came back. How much distance have you covered? What is the position you have at different time? And what is the displacement? The answer would be that the distance is from here to here to here to here. Let me say 1 kilometer, 2 kilometer, 2 kilometer and 5 kilometer. So the distance you covered is 1 plus 2 plus 2 plus 5. That is, it is 10 kilometer. But what is the displacement? Because at initial from here you started, then again you came back here. So the displacement is according to your position. You haven't displaced. You moved a lot, but you came back again to the same position. So your displacement is 0. Now this seems to be somewhat new for you, but we will discuss and you know that what is the distance and what is the displacement. So to locate the position of a particle, we always need a frame of reference. We cannot just say that this is a position. From where it is related, from where you are watching. So there is no rule or restriction on the choice of frame of reference. You can take any frame of reference. We can select a reference frame according to your convenience. It's up to you. Normally we choose this. This is X, this is Y, and this is Z axis, Z axis. Now any point, say here, 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 you can always find the X distance, Y distance and Z distance, and you can say, okay, this is the X, Y, Z position, X, Y, Z position of that object. Now you have a frame of reference. This is a reference point. You can start with this. This is a 0 reference point. And along the axis Y, or you can say along XY planes, YZ plane and XZ plane, you can easily point a value. The coordinate XYZ of a particle will describe the position of any object with respect to its frame of reference. This is known as coordinate system. So according to this reference, or you can say coordinate system, the position can be easily obtained. Now you started from here, say in time 10 minutes you reached here. In 20 minutes means in 20 minutes you reached here, so you took 30 minutes to reach here. So this is T1. At time T1, your position is this. At time T2, your position is this. T3, your position is this. Likewise, we will understand. And at this was T0, and again T5 is here only because you came here back. T4. So this is all the way in which we are going to deal with different aspects of your path length and displacement. So here is an idea. You were here, X1, Y1, Z1 at this point. Now at T1, you reached here, means you followed some distance, you followed some path, and at point B, at X2, Y2, Z2, that is the X distance, Y distance, Z distance from the coordinate system or origin, you are here. So this is from origin and this is again from origin, right? So this is a position of a particle in frame of reference, which is our X, Y, Z coordinate. So in this scenario, the position of coordinate of a particle in motion at time T1 is X1, Y1, Z1, and at time T2 it is X2, Y2, Z2. So this shows the position of particle with respect to given frame of reference, which is your X, Y, Z coordinate system. If all the three coordinates of a particle will remain unchanged with the time, then we say that the particle is at rest. That means X is 2, Y is 0 and Z is say 2. This is X, Y, Z position. Now with this is at T1, you say at T2, you are at 2, 0, 2. Again, now neither of X, Y or Z has changed. That means you are at rest. If one or more coordinate of a particle changes with time, then we say that the particle is actually moving. If any one, say this one, this one, this one, this one, or this one, any of one coordinate changes with time, then we can say that it is in linear motion. When an object is in linear motion, when any of these X, Y, Z, any one of these, only one of these position changes, other remains the same. If we have an object which is falling freely from top of a tower, the motion of a car along a straight road, these are example of linear motion. Now, when 2 or 3 coordinates, means not one but XX, YY, or say XYZ, so 2 or 3 coordinate change with time, the motion of particle is called two dimension, because one dimension has changed, linear motion. Two dimension change, we get 2D motion. When three dimensions have changed, we can say that these are three-dimensional motion. The earth which revolves around the sun, the striker moving over the carom board, these are 2D motions. But a butterfly, the butterfly is free to move in any direction, any way. So the butterfly may be changing all the x, y, z position. Then we say that the butterfly is moving or flying in three-dimensional motion. Let us describe the motion along a straight line. We will choose an axis and say this is an x-axis. Why we are choosing only one axis? Because in a straight line motion, only one of the coordinate change. Say x is the direction in which the particle or the object is changing its position or moving. So it coincides with the path of the particle, this x-axis we have taken. Now we can decide the position of a particle with reference to some origin. Okay, this is the origin, we have taken this. Now the position to the right, we will take it as positive, and if the object is moving this side, we'll say it is in the negative side. Okay, here positive, here negative. Now in this scenario, what is happening? The object is not starting from the origin. The object is starting from the position A, that is already 20 km ahead of O. Now the object has taken or is in motion and it moves to B. So how much distance it has traveled? 20, 80, that is 80 minus 20, which is 60 km it has taken. At 80, it turns back, it moves back till it stops to point C. Now again in the opposite direction, because this is 60 it has taken, in the opposite direction, from here if we say it is 60. Now again it is coming back, so it has to be in the negative direction. So 80, 40. How much distance it has traveled from 80 to 40? It is 40 again, but it is in negative direction, right? So this is the scenario we will be going to take in various discussion from now. So what is the path length? The path length is the total distance traveled by a particle in some time interval. This is called the path length or total distance. Which how much you have traveled is computed totally, and that is the path length. But the displacement is something different. That is the change in position of a particle in some time interval. This is the displacement. So there is a difference. If x1 and x2 are the initial and final position, and this x1 is at your position at t1, x2 is your position at t2, then the displacement in time interval, that is t2 minus t1, delta x, the displacement will be simply final position minus initial position. We are not worried about the in-between positions, only final and initial. You can say that I move from here to this point, right? So the distance is totally this plus this plus this, but the displacement is this one. This is the change in the position. If you try to find out displacement in this position, it will be this distance. Displacement from this point to this point, this will be this one, and this one I already told you. So displacement is different from the distance. The SI unit of both the path displacement and path length and displacement, they are known to be carried out in meter. So let us again talk about the difference between distance and displacement. Now the time interval was t2 to t1 in the discussion we had. The path length was what? Let us see. From 20, the object moved till 80. So what is the distance? That is 60. Now again it moved back from 80 to 40. What is the distance covered? That is 40. So 40 plus 60, this is the total distance covered. So 100 is the correct path length. But what is the displacement? I'll take you again to the diagram, because displacement has to be understood. Displacement is, it started from A and then came back to C. So ultimately from A it started, and after moving somewhere it came back to C. So this is the only path displacement. So 40 minus 20, that is, it is 20 kilometer displacement. So I hope you have got the idea of distance and displacement. So path length and displacement in this case are both positive. Displacement is directed in the positive direction if the car starts from B to C, as you saw in the figure. So path length was 80 minus 40 and displacement was 40 minus 80. In this case, the displacement was 40 minus 80, so it is minus 40 kilometers. The displacement can be negative. Distance will not be in negative, but displacement can be negative. So displacement of car is in x direction, and in the example we have seen car starts from A, goes to B, return to A. The total path length was actually 120, but the displacement is just 0, because if you say it starts from here and comes back to this point, then the total distance will be 120, because from this is 60 and again this is 60, so 60 plus 60 is 120. But this is A, and say the final position is say C, and it came back, A and C are in the same position, that is the displacement is 0. So path length is always positive, while displacement can be either positive or negative or 0. Okay. So displacement is just the resultant effect of motion of car from where it started and where it ended. This is displacement. And displacement both have magnitude, as you see this is magnitude, and also the direction. If you landed here, this is the magnitude, but this is the direction. These are the directions, and these are represented by vectors. We'll learn about these vectors shortly. So in one dimension motion, there are only two directions. It can be either this way, or either this way, that way. That is backward, forward, upwards, downwards, in which the particle can move. And if we take this as plus, we have to take this as minus. If we take this as plus, this is minus, and vice versa. So a particle moves along a circle of radius r. It starts from A. In anti-clockwise, that is in the opposite way the clock moves. Calculate the distance traveled by the particle and the magnitude of displacement of each of the following case. So from A to B. Now A to B. Before we discuss about this question, first is a circle, and we know that the circumference of a circle is 2 pi r. This is 2 pi r. Now this is the 1/4 of 2 pi r. So this will be 1/4. The distance will be this one. How much is this from A to C? This is 2 pi r by 2. So distance will be this. How much about this? This is 3/4 of a 2 pi r, right? Yes, this is 1/4 of 2 pi r, so this is 3/4. And how about this? If it starts from A and come back to A, what is the distance? This is complete 2 pi r. So these are the distances. Let us know the displacement from A to B. Now the displacement is this one, not this one, but this one. So this is r square, this is r square. We'll use the Pythagoras theorem, r square plus r square under root. This will give you under root 2r. And when it reaches AC, what is the displacement? R plus r, so 2r. Again, when it reaches D, what is the displacement? Again, because this is r, we'll again use the same formula, and this will be under root 2r. When it comes back, it will be 0. Displacement will be 0, and distance will be total covering. So this is what is being shown here. Distance traveled by a particle from A to B is 2 pi r by 4 in the first case, A to B. And the displacement is under root r square plus r square, that is under root 2r. And from A to C, that is on this point to this point, it will be 2 pi r by 2, because whole circumference is 2 pi r. So it will be 2 pi r by 2, that is pi r. Displacement is what? R plus r. This is from here to here, it is r. From here to here, it is r. So displacement is 2r. From A to D, that is this point to this point, this has to be taken totally. So this is 3/4 of 2 pi r. 2 pi r is the total circumference. So we have to take only 3/4. So this will be the path length, and displacement again will be under root r square plus under root r square, under root 2r. But at this final position, if we come back here, the displacement will be 0 and distance will be whole 2 pi r, which is being shown here. The path length will be 2 pi r, displacement will be 0, because the particle has come back to its original position, and because it has traveled totally, the path length or the distance will be 2 pi r.